Hello and welcome to the Cisco AI Insights Podcast, where every month we invite a technology or AI expert to the show to highlight and discuss trends, news, and academic papers from the worlds of AI, machine learning, and data science. I am one of your hosts, Rafael Herrera, and my co-host is a machine learning engineer and data scientist in Cisco's customer experience team, Sónia Marques. Welcome to the show. How's your day going?
Hi, all great.
Fantastic. And this episode, we're moving beyond static benchmarks to explore a groundbreaking time horizon metric that qualifies how AI agents are rapidly accelerating from simple tasks to complex multi hour software engineer projects. To help us unpack these findings and their impact on our development life cycles, we are joined by Paul Mutawe, a Cisco ML engineer. Paul, welcome to the show. How are you doing today?
I'm doing good. And yourselves?
I'm doing pretty well, actually. It's a little bit toasty where I am, but hopefully everyone's feeling comfortable wherever they are. And before we dig into this paper that you brought us, first off, talk to me about AI agents. How do they work? What's the deal with AI agents? And what are we trying to benchmark exactly?
LLMs from when, let's say around 2022, when GPT, let's say 3 came out, people typically used LLMs for certain usual responses to things, like without the model requiring any external extra tools or any external extra context. The user would input all the context required, and then they would receive a certain output. Where the term agent started forming was an LLM which was provided tools and extra context and the ability to gather extra context to then answer a much larger question or problem or task. So an agent is an LLM which is able to orchestrate extra tools and gather extra context in order to provide you an output.
A quick question about that, actually. Does it also qualify when I remember those days long ago when ChatGPT first came around? It didn't have access to the internet. Does that make it
I
an
think
agent?
an agent will be an LLM that now can search, can
Okay.
use the internet, and that's considered a tool. So that's now considered an agent because it's able to use a certain tool to then come up with, find any additional context if you haven't provided it with all the context required for it to answer the question properly, and then it will provide you an answer.
Okay, so the threshold is a little bit lower. It doesn't have to be too complex. Even something as simple as the internet could make something qualify.
100%.
All right, perfect.
100%.
Yeah, I think it's one of those terms that gets thrown around a lot, and it seems like a bit intimidating even. But it doesn't have to be that complicated. If there's like a wrap up around the LLM that makes it like have memory and act in the world somehow, go to the internet, like you said. I think, at least in my point of view, because there are multiple definitions, but yeah, it is considered an agent overall.
Okay, that sounds like an excellent operating definition for today because it sounds like
Yeah.
you've got an interesting paper to talk to us about benchmarking these AI agents.
Yes. So there's a research team for model evaluation and threat research who wanted to measure AI's ability to complete long horizon tasks. We've reached a point with AI agents where we're able to orchestrate many tools, we're able to provide it much larger context than we previously could. So we now want to assess how far we could push these models. We're trying to establish how long of a task this AI agent could successfully complete without any human intervention.
But I think it is important for us to just from the start to clarify what long means now. So it's a measure of time, but is it a time for the agent to complete the task or not?
Exactly. The team from METR, they come up with a term called the time horizon, which is the human time to complete a task and the AI agent's success rate for that task. And I can elaborate. For example, if a human being can complete a task, let's say that takes an hour, a 50% time horizon is the AI agent's ability to complete that 1 hour task successfully 50% of the time. The main finding of the paper is that this 50% horizon is doubling every 207 days.
And before we get too far, the name of the paper is Measuring AI Ability to Complete Long Software Tasks. And you said that was from MIT, right?
METR, a
And
team called Model Evaluation and Threat Research.
okay, perfect.
MET.
Just want to make sure we got that clear because we're going to be talking all about them and I want them to get all the credit from that. So go ahead, Paul, jump right in. Give us the lowdown on this whole thing.
Yeah. So then they look into a distribution of many tasks, around 170 tasks. There's a mixture of engineering heavy tasks, which take human beings hours to complete. There's a mixture of atomic tasks, which are around seconds to a minute long, like just changing a variable. And then there's a mixture of certain software engineering related tasks, like writing a Python test and so on and so forth. So the reason why they chose this distribution is to try their best to reduce bias that could reflect the real world to the best of their ability.
It's a very tricky endeavor, this benchmarking challenge. I know they tried, like you said, to make every model that is being studied in this paper to have the equal opportunity to shine in the results. And there's this concept that is talked in the paper about the hardness
Yeah.
that the model uses. Can you expand on that?
Yeah. Yeah. So a harness or a scaffold is a lot of a buzzword these days in the community. They call it an AI agentic harness. And this is the environment within which the LLM works. So this harness, it tells the LLM the amount of tools it has at its disposal, whether it can search the internet, for example, as a tool, whether it can write a document, edit a document. Those are all kind of tools. And also how it interacts with the user. A harness could tell the user at which point it needs more context. Oh, I can't answer this from the context you've initially provided. Could I have more context or could I search for more context? And each harness from different frontier labs has a bias towards the models that those frontier labs create. For example, Anthropic's harness called Claude Code performs best with Claude Code. OpenAI as a frontier lab, their harness codex performs best with GPT. So what they did to reduce the bias was use a harness called Modular Public so that all these models being tested are on the same wavelength.
I never thought about that bias that harness and the LLMs have, but yeah, it makes total sense. And for these types of studies, they need to be leveled
Yeah.
out. Another thing that they also gave a lot of importance to in the paper was trying to make the tasks that are being used to benchmark these models as fair as possible, as varied as possible, and try to make them be meaningful in the real world, though they obviously explain the limitations that these things, at least in the near future, will have.
Yeah.
Can you explain a little bit more about that topic?
Sure. So I think I can touch on the messiness factor and then I can go into many other aspects. So in the real world, there's more complexities with regards to stakeholder communication, collaboration on a very long horizon task, additional context provided, perhaps extra tools. So the researchers tried to add in something called the messiness factor. And a messiness factor is a 16-item checklist of certain real world things that they feel would make a task more difficult. So whenever a task within any of the benchmark data sets, let's say the RE benchmark, which is the research engineering data set, which takes tasks that can take up to 7 hours, they would list how many messiness items this task likely has. Let's say its final goal with regards to how successful or how good a task is unclear. It's not like a correct or wrong. Let's say there's a range on how well this model could be, how many external context or documents it requires, how many different tasks the agent needs to run to get to the final result. Perhaps it needs to pre-process data first, then train the model, and then evaluate. Every messiness factor was said to decrease the mean success rate of an AI agent by up to 8.1%. So we saw that in the paper, the higher the task's messiness factor, the lower the observed score.
That was a very interesting part of the paper. And I think, especially now, we're talking a lot about the spec driven development.
Yeah.
And it really highlights how important it is for us to really leave no room for assumption to the LLM
Yeah.
because it doesn't deal at all with this type of ambiguity. It really highlights how specific we have to be with the requirements when we ask for an LLM system to complete a task.
Yeah,
Complete a task.
exactly. And actually, to even add on to them trying to have real world analogies, they tasks these same frontier models with that modular harness on internal repo issues. And what that means is certain actual real world repos from engineering teams had these frontier models take on these certain issues, and the repo maintainers would then manually score how well these models did. And in comparison to the benchmarks, which have very fixed scoring and have isolated environments to complete the tasks, they performed really badly on the internal PR issues.
We can now talk a little bit about the results because they are really analyzing deeply the trend of these 50% time horizon metric
Yeah.
for multiple models over, I don't know how many, it was 7 years or something like
Yeah.
that. So yeah, I think we can now jump into some of the results and the discussion.
Yeah, so sure. So the model that performed the best actually was O1, which had a 50% time horizon of about an hour and 50 minutes, which I think is quite good. And the model which performed the worst was GPT-2, which was a 50% time horizon, I think I recall, of around 10 seconds. And then they say they naively extrapolated that from the slope, they predict that frontier models will be able to complete tasks that last about 4 weeks long in by around 2028 to 2031. So that was quite interesting. But I think an important aspect of the results that we have to, like a caveat of the results, is that's a 50% success rate, which is not necessarily production grade acceptable. If an AI agent is only able to complete this task 50% of the time, then it's likely not as reliable as we think. We have quite a while to go before we could allow
Yeah.
AI agents to autonomously do all the wrong.
And so, question about that. Is that an uncommon situation, though? Is it really pushing it to the extreme? Obviously, 50%, you toss a coin up and it will or won't work, right? But it was, what, 4 weeks long? If you had something shorter, does that impact that result at all?
I think 100%, because I think the context within benchmarks is that when AI agents are being used within a team, it's unlikely that they would allow them to go ungoverned for 4 weeks, especially for a task within which we want to push to production in front of users. I think that's almost in fact, I think that's not possible. What these benchmarks are showing is researchers pushing the models to their extreme capabilities with absolutely zero human intervention. So in terms of being team LLM, I would say that these scores are promising because it's unlikely that any ML researcher or engineer would not check in and see how well the task is doing or guide it on the right path if it felt like the results and the validation accuracy of a training model is not going according to plan.
Yeah, I really like that take, Paul. That yeah, they're pushing the limits and
Yeah,
seeing how it goes doesn't mean that it's realistic
exactly.
or set production ready type of system. But still, even if it's 80%, a human would have, if it's a critical system, someone would have to take accountability. At least in the near future, we don't know how software development will evolve, but I think it is still interesting to know how these models are evolving over time and it's being very quick a quick development that we are
Yeah.
seeing.
Yeah, and kudos to, I think, the METR team. Whenever I read a paper on benchmarking, I appreciate how difficult benchmarking is because there's so many variables you have to take into consideration. For example, testing a model in and of itself and the harness within which it's performing are two different things. Finding the correct human baselines where you're trying your best to find human beings at maybe around the same level, or sometimes I think is also a bit difficult.
And the paper is 10 pages long, but
Yeah,
with the appendix it's 45.
exactly. Exactly.
They put all the data, all the details, like even the hyperparameters. They try to, as much as possible,
Yeah.
analyze everything and give, like I said, each model the same chance to thrive. Though we know that it depends. Maybe they were introducing some bias by mistake, but I think they did what could be done in such a challenging task.
Yeah, very challenging task. And there's many limitations in future work which they mention. For example, looking closely at the prompts that they used for some of these long horizon tasks, thinking about the compute cost, not only of the successful runs, but also of the runs where the model failed, because that's also an important aspect to note. Because an aspect of the paper that they noted was that around 80% of the AI agent's successful runs cost about 10% of what a human being would cost. And that sounds like an impressive statistic on the front end, but you forget that it's only counting the successful runs. What if it failed 99% of the time for that task, or 50% of the time? It didn't include the compute cost in that aspect.
And the cost of the human to decide which was the successful run and really go through all that code that a human would have developed in 4 weeks. That's not like the PR
Yeah.
open PR rate that we are used to. So that would be a lot of code to review. And it usually makes more sense to even check in with the system what it's outputting at each step and give feedback. But like you said, it's a very challenging thing to benchmark, and they were pushing the limits of what it can do autonomously. And I think still the results are very interesting and very promising.
Yeah. And another touch on the compute costs. They said for future work, perhaps they could spend more time on inference time compute. And what that means is inference is when a model is outputting a certain input after taking in context. For more inference time compute, if it's using perhaps a better harness, they could have ran parallel results at once. So they could observe which parallel agent is doing better. And those are the kind of things that people using the usual harnesses like GitHub, CLI, or Claude Code or Codex are doing. So I think the harness aspect really limited a lot of the results that we saw from benchmarks.
I think it is a bit off topic.
Yeah.
But one of the limitations in future work that they discussed is testing broader domains.
Yeah.
Because these papers always go for software engineering and maybe like very I know why, because it's easy to have a right or wrong answer. But there are other fields, even customer support, for example.
Yeah.
Maybe these results will translate to other type of tasks like that, like dealing with a human when it has a problem at hand. But we don't know that. It would be interesting to see how that differs.
And that's what I think as well has given me more appreciation for benchmarking teams. Extrapolating these results to other domains is not, you can't really easily do that because other domains require different ground truth, and collating that ground truth for things like the law domain is very difficult, I think.
And really quickly, before we jump any further, please tell us, what is ground truth? Because I've been hearing that term a lot with AI, and what does it actually mean to the normal person out there?
So ground truth is essentially how we tell that something is actually correct, and it's the likely a subject matter expert who would tell us that this is something that's correct. If, let's say an LLM was producing a legal document, it's the legal experts who would tell us whether something is exactly correct or not in order for us to determine if what the AI agent has produced is what's expected. So ground truth is just something that's confirmed correct by an SME.
Yeah, it's basically our gold standard to answer a specific task or question that is usually given by an experienced SME.
Yeah.
Then, okay, obviously this is a very hefty task, benchmarking anything, because people use these tools in a variety of different ways, and nobody can really standardize that because in the real world, it is pretty much impossible. You might just have a slow internet connection and things might be strange or different. You never know, right? So, with things like ground truth, obviously we're using that to compare. And how has that followed through with something like an agent like this? So what has the paper really shown? Does it matter too much? Were there things that got in the way more so than other times?
I would say, and hopefully this answers your question clearly, I would say for the benchmarks of the task distribution, let us say the HCAS software, the short atomic tasks, and the ML engineering tasks, they were very clear ground truths within the data set. So we could easily tell whether something is correct or not, or how correct it was or not. Where things got difficult is like the internal PR issues, where they tried to mimic the real world by just providing the AI agents with a real repo, like us providing the AI agent with our repo with limited context, and us as repo maintainers being because we know the ground truth of what we think is correct. We're the SMEs in that aspect, judging how the AI model is performing.
So do you think that it performed to what we were hoping it would perform to?
I think so, yes, because I think for benchmarks and task distribution that is already out in the internet, a lot of these LLMs are trained on a lot of them on a certain input with an expected output. But as soon as you try and extrapolate that to a real world task, which an agent has never ever seen before, I think that's where the difficulty comes in, like the internal repo issue I was mentioning. So hopefully that answers your question. And actually, I think the lack of ground truth is why I think enterprise AI implementations are difficult, because we continuously require SMEs to validate what we've done, because if we want to ensure that something's correct. If we're making an AI product for the sales or marketing team, we need the sales and marketing SMEs to confirm with us that what we're doing is really good or really bad. Otherwise, you're just propagating something that you haven't measured throughout the company, essentially, with all these AI products. So yeah, so that's why I think benchmarking is very important and very complex.
So Paul, it doesn't sound like you have much faith in this whole system. This whole AI agents thing might not be for you.
I'd say I'm very LLM leaning. There's a lot of skeptics out there in the world, but I say I'm very LLM leaning because they can never be, like you said, a perfect harness that doesn't require any human intervention. I don't think that's even really possible to cover something that can complete a problem, start to end, that's very complex, without any human being intervention at all. But I think from what we're seeing of how the time horizons are literally doubling on very complex tasks that have an increased messiness, that have less and less human intervention, I think that that's good enough for me. I think that showcases that LLMs have a lot of capability with human input, with a human in the loop.
Yeah, it's getting much better at a very high rate. So I think, yeah, we can maybe assume that it's more and more reliable and maybe give like the check-in less frequently. I think that's the best takeaway, perhaps.
Yeah.
We can trust it a little bit more over time. But I'm not an LLM skeptic. I use it every day. But I still have to check every output that it does.
Yeah.
You're quite right, but maybe it's my prompting skills that need some polishing.
And that's an important aspect that Sonia just
Yeah,
mentioned.
it's challenging.
The limitation of and future work mentioned in the paper is the prompt itself. What are the initial instructions that you're
Yeah.
providing the agent to perform a certain task? If someone provides limited instructions for context, and that the harness is not able to gather more context in any way or ask for clarification, the agent will likely not perform as well in a certain task where much more required documentation, not necessarily providing it with 10,000 documents.
Required requirements.
Yeah, required requirements. Because there's something called, actually, not to branch off, but something called context rot, where necessarily just providing more context to an agent doesn't necessarily mean that the result will be the best.
Has to be walkable information that we are having.
Yeah.
So with an AI agent, less is more, but that less better be good. Is basically what you're saying.
Yeah, essentially, yeah.
Thank you, Paul, for coming on the show. I know that I'm not feeling better about AI agents at this point. I think I will wait before I let it use my bank accounts, but it seems like we're on our way at the very least. Maybe it will happen one day, and we're getting there. At the very least, having a benchmark is a step in the right direction, so we know if things are going well or not. So fingers crossed, we figure all this stuff out very soon. Thank you very much again, Paul, for coming on the show. And if you like conversations with experts about AI, machine learning, and all the other emerging data science technologies rapidly shaping our world, please subscribe to our feed wherever you get your podcasts. We will be releasing episodes every month and would love to have you along for the ride. So until next time, I am Rafael, I have Sonia, and we've got Paul here. Thank you for listening, and we'll catch you next time. Bye-bye.
Bye-bye.